Let's try this example. I have 100 grams of water. It's at 22.4 degrees Celsius. And I put it into a calorimeter. And then I have separately a 75.25 gram sample of aluminum that I have in hot water. And that hot water is at 99.3 degrees Celsius. And that if I leave that piece of aluminum in that hot water that's at 99.3 degrees Celsius, logic says that eventually that piece of metal will get to the same temperature if it's sitting there for so long. And then I take that piece of metal, that aluminum, and I quickly put it into the calorimeter. Remember, the calorimeter's got 100 grams of water. It's at 22.4 degrees Celsius. Common sense says that if you take a hot piece of metal and you put it into water, that the water is going to get hot, right? Common sense also tells you is that if you put a hot piece of metal in water and the temperature of that water is colder, the temperature of that piece of metal is going to go down. And when the temperature of the water goes up in the calorimeter, the temperature of that metal goes down, they end up at the same temperature of 32.9 degrees Celsius. And the question is, what is the specific heat of that aluminum? Well, the thing to remember is that whatever energy that the water gets is coming from the aluminum. So if we can figure out how much energy the water is getting, then you know how much energy the aluminum lost. Okay, and if you can figure out how much energy the aluminum lost, that'll lead you to its specific heat. So let's see how we do this. So the first thing you got to do is figure out the heat transferred to the water from the aluminum. And then the next thing you have to do is figure out then the specific heat of the aluminum. So first things first, what's going on with the water? So the water has a specific heat times mass times delta T, where the specific heat is 4.18 joules per gram degree Celsius from the table. The mass of the water is 100.0 grams. And the change in temperature of the water is 32.9, the final temperature minus the initial 22.4. You get 10.5 is the difference in temperature. So to figure out the Q of the water, the heat transferred to the water, you need the specific heat, the mass, and the change in temperature. Bing, bing, bing. And when you do that, you get 4,390 joules. So that's how much energy was transferred to the water. And that energy was transferred to the water from the hot piece of metal. So how much energy did the hot piece of metal give it? 4,390 joules, right? So in the same process, the Q, now let's do the Q, deal with the Q for the aluminum. Do we know the heat transferred from the aluminum? Yeah, that's the 4,390 joules, whatever the energy that the water got. Do I know the mass of the piece of metal? And the answer is yes, 75.25 grams. Do I know the change in temperature of the metal? The metal was originally at 99.3 and it went down to 32.9 for a change in temperature of 66.4 degrees Celsius. So if I know my Q, I know my mass, I know my change in temperature, I can solve for my specific heat, which is 0.879 joules per gram degrees Celsius. So this is a way of figuring out what something is. If you know all the information, you can figure out what it is, calculate its specific heat, and they'll say, that's the specific heat of aluminum. And you can figure out what aluminum is from that.